Welcome to the 39th video in our series about Unix tools. In this video, I will show you more things you can do with the BC utility. But first, let's remember what we learned in video 38. We learned that when we run BC, we normally want the -L option to get the math library, which includes 5 functions, SC, A, L, and E, which are the sine, cosine, arctangent, natural log, and exp, or e raised to the power x. We also used several binary operators, plus, minus, star, and slash for addition, subtraction, multiplication, and division. We also had percent for the remainder, but you need to remember to set scale equals 0 if you want it to act like mod, and it will for positive numbers. And we can raise to an integer power using the caret or hat. We also learned about 3 settings to the system that are done by assigning values to special variables. Scale, which tells you the number of places after the decimal point to give you the arbitrary precision. Ibase and obase, you should only set one of these to specify the input or output base when you don't want to use decimal or base 10. And this system uses decimal math, not binary floating point, so it gets more accurate answers than you're going to get if you use the normal routines from the C library. So here are 3 questions we want answers to. How can we get the tangent? Sine and cosine were built in, but tangent was not. How can we raise a to the power b when b is not an integer, when it's some arbitrary floating point value? And the last one, how can we get the cube root of x? So those are some pretty good questions. And to do it, you're going to have to think back to your old math classes and realize there are formulas for those things which use other functions that we do have. Tangent is just sine divided by cosine, and we've got sine and cosine. Pow, that's the name of the C function, but it says raise a to the power b, and you can do that for any b using exp and ln, or edx and natural log, and we have those functions available. And cube root, or any root, the nth root, is really just x to the 1 over the root you want. So the cube root is x to the 1/3 power. The 5th root would be x to the 1/5 power. The nth root would be x to the 1 over nth power. So great. One of the things we're going to learn how to do today is define our own functions, because BC is programmable. Okay, let's get out of the README and get busy. Maybe, if we can here. I keep hitting the wrong key on my keyboard. There we go. So let's get into BC minus L and ask ourselves, how do we define tangent? That's the easiest one. Well, we can do define, and we only get one letter, so we'll call it T, and we'll have our angle A. And then what we say is return the sine of A over the cosine of A. And then if we want to get an angle where we know the answer, right? The tangent of 45 degrees should be 1. So let's use that. 45 degrees, how do we get degrees into radians? Well, if you remember from the previous video, I said pi could be defined as 4 times the arctangent of 1. So that gives us pi. And if we take the tangent of pi over 4, it should be a number very close to 1. And you can see, yes, if you round that number, you get 1 correctly. So we've successfully defined tangent. Good, that was one of our first goals. The next thing to do is to define a power. So we define P, and it's going to need, y to the x. And how do we do that? We're going to return e to the, and we're going to take the natural log of y, and we're going to multiply by x. Okay, so let's take the power, and let's try some integer power, just like we did before. So 2 and 8, it's very close to 256 if you round it. But now we can do things like 2 to the 8.1, and we get that number. And we say, okay then, I'm pretty happy with that. How can I get the cube root of 27? What's the cube root of 27? Well, 3 times 3 times 3 is 27. So the cube root should be 3. So if we say, aha, that's just the power to the 1/3. So if we say P of 27 to the 1/3 power, you see it's very close to 3. So we've solved the missions or found solutions to the 3 questions that we had, which was, how can we get a tangent? How can we raise to a non-integer power? And the sort of sub-question, how can we get the cube root of something? And so there it is. And you can do whatever root you want. So if we said 2 to the 5, that's 32. So if we take the 5th root, we should get a number very close to 2. And we do. 1.9999. So the tool works. It uses decimal math. There's only the annoying problem that it doesn't do the rounding for you. You have to do the rounding yourself. That's life. Sometimes you have to do your own work. So can we do other things with this? Let's say we wanted the sum of the first 10 numbers. Can we do that? It turns out there is a for loop. Oops. That works very much like the C for loop. And you get 55. And you say, wait a minute, you did not initialize A. It turns out when you start the program, the normal variables are initialized to 0, but you're right, we should initialize first if we were going to be better people and safer. And then we show A, and it's still 55, even when we initialize it. So we can do a for loop to do simple sums or simple products. And you begin to see that while the syntax seems alien, and we have to do the rounding ourselves by hand on the final answers, this is a very powerful calculator, and it's always there. Any Unix system has to have BC. And this gives you decimal math of whatever precision you want by setting the scale. Python, a popular alternative programming language, has decimal support, but if you've ever used it, you know it's extremely verbose. The only other language where decimal arithmetic is really easy is Rex, but Rex is rarely installed on machines that are not mainframes. So BC is your friend. I want to thank you for listening, and just in case you've decided that BC is a nightmare and you never want to see it again, don't worry, our next video will be something completely different. Thank you for listening.